Welcome back to Ecto 3D Printing. Today we're talking about some of the methods that we can use to calibrate and tune our AnkerMake M5. We'll be going over bed level testing and some calibration cubes. So stick around, let's dive in. The first thing we're going to take a look at is a bed level test. So with this, it just prints a thin layer on the print bed. So it just shows you any places where the bed might not be perfectly level. So this was my first attempt, and you can see it kind of peeled away in this corner, and there's a lot of gaps and stuff in the middle. So that was not a great test. So I ran the auto bed leveling on the printer and then printed another one, and it turned out much better. There's still some gaps here and there, but it's pretty close, and it's close enough for me. So that's one thing you can do to figure out the levelness of your print bed. Now another thing that you can do, like I showed in one of my other videos, is this print tower test, overhang, and tolerance test. This is preloaded onto the printer in the Autodesk Kickstarter or something file on the local storage of the printer. It shows you overhangs, bridges, points, roundness of holes, tolerance of pegs, and different things like that. So it just shows multiple things that you can use to kind of gauge the capability of your printer. Alright, so the next thing we're going to do is we're going to jump into some calibration cube testing. Now, in all of my videos, I keep saying that I'm not an expert. This is my first 3D printer, and I'm just showing what I learned. So be careful with the values you change in this next process. I'm not responsible for any damage you cause to your home printer. So with that said, let's jump over to the whiteboard and check out how we can use these calibration cubes to do some simple calculations to tune our machine. Alright, so let's go over some of the math that we need to calibrate our stepper motors on the AnkerMake M5. And the first thing we need to do is find out what the current stepper motor values are. So to do that, we need to go into the AnkerMake app on our phone and go into the settings of the printer, check About Device, and then we need to access a hidden menu. And shout out to the print house for showing how to access this menu. To do so, we just need to touch and hold the version for about 4 seconds until this option at the bottom appears, Advanced Parameters Beta. So we come into here, and this is all of our fine-tuning settings for the printer. Don't mess with things if you don't know what they mean. Today we're only going to be messing around with motor pulse. This is our stepper motor values. So let's start off by logging our current values. So let's start off by 1, X, Y, and Z. And we have 128, 128, and 400. So these are our default values. Now what we need to do is print a calibration cube with these default values, and that's what we have right here. This is cube number 1 for our values. So with our cube, the first thing we need to do is measure the values of our cube. So this one is the default, that has nothing changed. And we have X is 19.9, and we have 19.9 for our X. Let's go with our Y. Let's see, Y right here. This one, our Y, 19.7. And now our Z value, 20.1. Okay, perfect. So now what we need to do is calculate the percentage off that these numbers are. So what we need to do is take the original dimension, what the models should actually be, which is 20 millimeters by 20 millimeters by 20 millimeters, and take that, so 20 millimeters, and we need to divide that by these values right here. So to do that, divided by cube 1. We need to go into our calculator. So we need to take our 20 millimeters and divide that by 19.9 for our first one, which we get 1.0050. And let's do our second one, 19.7, and we get 1.0152, and do our last one, 20.1, and we get 0.99. So with these new values, what we need to do This is basically the percentage of scale that this cube resulted in. So we need to take these values and multiply them by these values to get the new stepper motor values for our second cube. So to do that, what we're going to do is let's just take these values and multiply them by 128, multiply by 128, multiply by 400, and that should give us our new values for our second cube. So let's do the math on these. We have 1.005 times 128, which is 128.64. Now let's go on to our next one. So these are the new values that we need to type in to our motor pulse for our second cube. Now, one thing interesting is that you can't do decimal numbers in here, so you just have to round to the number that seems to work better. So let's start off with, let's just round up to 129 on this first one. Let's just round this one up to 130, and this one, let's go to 398. And we'll print our second cube, and we'll see what the dimensions are. Alright, so we have our second cube here printed. So what we need to do is find the dimensions of this cube. So let's take a look at the previous numbers compared to the cube number 2. So 19.9 stayed the same. 19.7 went up to 20, which is great. That's about spot on where we need it. So we'll leave that one where we have it. And then 20.1 didn't seem to change much. So let's redo X and Z for a third cube. So what we need to do is do the same math that we did here. So let's do the same math of 20 millimeters divided by each of these values. And we'll just do the X and Z for these values. So let's go into our calculator. So since that one didn't quite change, so let's just go up to 130, and we'll try 130 on this one. So Y we don't need to change, and this one is still 398, but let's go ahead and try 394. Let's just go a little bit further than we might need to, and we'll see how that goes. So let's enter these in here. Now let's go ahead and print our cube number 3. Alright, so we've printed our cube number 3, and here we have it. So let's take a look at the measurements for this cube. So let's take a look at our X. Our X is at 20. Perfect. That's exactly what we needed. And our Y shouldn't have changed, but let's just double check. 20, yep. Perfect. And let's take a look at our last one, which is the Z axis. And we have 19.8. So 394 was too far because we were at 20.1 before. So what we're going to do is we're just going to split the difference between 394 and 398, and we'll go with 396. So let's change our value to 396, and I'm comfortable enough just leaving it at that value because we've done both extremes of it, both extremes of the value, so I think our final numbers will be fine. So our final X, Y, and Z are 130, 130, and 396. So those are our values for our stepper motors. And that is some of the math that you do to calculate the stepper motor calibration. Now, I'm not an expert, and again, these numbers aren't for your printer, these are for my printer. So you have to do this process for your own printer and figure out these numbers for yourself. Now again, this is the calibration cube that is 20 millimeters by 20 millimeters by 20 millimeters, printed at 0.1 layer height in order to get the finest detail that we can. and measure our dimensions accurately. So I'll provide a link for this calibration cube in the description, as well as the guide that I followed to figure out this math. So check those out in the description below. Alright, there we have it. That is how we can tune the stepper motors of our machine using a 20mm calibration cube. I'll provide links to these tests in the description below, and you can check them out for yourself and try this out. And if you have any questions, let me know down in the comments. Again, I'm not an expert. I'll try to answer them the best I can based on my knowledge of what I've done. And until the next video, we'll catch you later.